All right, so now that we've talked about how to fit these decision trees, these boosted decision trees, let's talk about what parameters are being tuned and how to actually do that. So as a refresher, with bagging, what can we tune? So we can tune the parameter B, which is the number of bootstrapped training samples or the number of decision trees fit. In R, this is trees. And it's actually more efficient to just pick something very large for this instead of tuning it. For B, you really don't run the risk of overfitting if you pick something too big. So you can kind of just pick something quite large and it will be okay. With random forest, what were the things that we tuned? So now we have two things. We have B, and we also have M, the number of predictors to try. And so in R, this is M try. And so the default for that M try is the square root of P, and this does pretty well. There's not a huge reason to tune it, although of course you can if you'd like to. And so now for boosting, we have B, the number of bootstraps, and then we have two additional parameters, lambda, the shrinkage parameter, and D, the number of splits for each tree. And so unlike bagging and random forest, with boosting, you actually can overfit if your B is too large, and so it's good to kind of keep that in mind. So what do you think you could use to pick B if you have to be worried about overfitting? Cross-validation, of course. And so this is kind of the answer to most of our questions, or actually all of our questions when we're doing tuning, is cross-validation is going to help us with that bias variance trade-off where we can find that sweet spot where we don't overfit and we can kind of minimize that test error that we're trying to do. So that's what cross-validation is good for, and it's perfect for being able to pick that B. The shrinkage parameter lambda, this controls the rate at which the boosting will learn. And so lambda is usually small. Usually, so it's going to be a positive number. Typically, it's something like 0.01 or 0.001. Again, you can tune this, but the conventions tend to work pretty well. And it also depends on the problem, but typically a very small lambda can require a very large B for good performance. And so these are sort of interrelated, and that needs to sort of be kept in mind as well. And then the final parameter that we tune with boosting is the number of splits. And so this is this is D from the way that I wrote it in the algorithm before. And so in each tree, this basically controls the complexity of the boosted ensemble. And so often D equals 1 is actually a pretty good default. Here comes another tree pun. When you have D equals 1, we call this tree a stump, and that's because it just has one split. So when it just has one split, we call it a stump. I just love all the tree puns with decision trees like random forest and stumps, and we're growing our trees, and it's great. And so when you set D equal to 1, where you just have stumps in each case, this results in an additive model. And so you can sort of think of D as the interaction depth because it controls the interaction order of the boosted models. And that's because D splits can involve at most D variables. And when you're thinking about what's happening when they're splitting, if you have two splits, it's kind of like you've set this like double interaction.